All right, if you've ever built a PC, you've definitely been there. You're staring at a list of motherboards and you're thinking, wait a minute, these specs look almost the same, so why in the world is this one $300 more than that one? It's a super common question, and today we are going to pull back the curtain and find the real answer. And hey, this isn't just some made-up problem. Let's kick things off with a real question from a user, John Arcos, who just perfectly nails this exact confusion. He's looking at some X570 boards for his high-end Ryzen 9 CPU and is just staring at this massive price range. Just take a look at this list he was looking at. You've got the MPG X570 Gaming Plus down at €190, and it goes all the way up to the Carbon EKX at €500. I mean, that is a gigantic gap. He even says the only real difference he can spot is the number of M2 slots. But come on, that can't be the whole story, right? Okay, let's dive in. To find the answer, we have to ignore all the flashy RGB lights and the cool-looking heatsinks. We need to zoom in on a part of the motherboard that is absolutely essential to your PC's performance, but, almost never gets the spotlight. This right here is the voltage regulator module, or VRM, and its job is one of the most important in your entire system. The best way to think about it is like a super sophisticated dam for electricity. It takes this massive 12-volt fire hose of power coming from your power supply, and it carefully, precisely refines it down to the perfectly stable, super low voltage, we're talking around 1 volt, that your delicate, very expensive CPU needs to actually work. Now, on the surface, the process sounds simple enough, right? It gets 12 volts in, it does some magic, and it sends about 1 volt out to the CPU. But it's that middle step, step 2, how it converts and cleans that power. That's where all the brilliant engineering and, you guessed it, a huge chunk of the cost is hidden. So, as you've probably figured out by now, not all VRMs are built the same. Not even close. In fact, the whole design philosophy behind a budget VRM and a premium one, well, they're worlds apart. So how are they different? Well, the budget boards, they save a buck by using a bunch of separate little components called MOSFETs to do the job. Think of it like a bucket brigade. Sure, it gets the water there, but it's messy, it's not very efficient, and you waste a lot of energy as heat. Premium boards, though, they use a single, highly integrated component called a power stage. It basically combines all those separate parts into one slick, super efficient package that runs way cooler and can be controlled with much more precision. And here's the real kicker. If you take a powerful, power-hungry processor and you pair it with a motherboard that has a cheap budget VRM, that VRM can get totally overwhelmed. It'll start to oversheet, and to protect itself, it'll tell your expensive, high-performance CPU to slow down. It literally becomes a performance bottleneck, and it doesn't matter how amazing your CPU cooler is. Okay, so we know premium VRMs use better parts, but let's zoom in even further. Let's get out the microscope and look at the tiny little component that acts as the conductor for this whole electrical orchestra. This little guy is the PWM controller, and that stands for pulse width modulation. You can just think of it as the brain of the entire power delivery system. It's like a microscopic traffic cop directing huge amounts of power with just incredible precision. And this just brilliantly illustrates the insane complexity we're talking about. This is not a subway map, okay? This is the functional block diagram for a single PWM controller chip. Now, you don't need to understand what every single line means. Just appreciate the sheer density of engineering that is packed into something smaller than your fingernail. It's amazing. So what is this chip actually doing all day? Well, in simple terms, it's in constant communication with your CPU. It's listening for exactly how much power the CPU needs at any given millisecond. It's telling all those power stages how to deliver it, and this is crucial, it provides a safety net. It's protecting your expensive components from things like power surges or overheating. It's a bodyguard and a manager all rolled into one. All right, we've been deep in the tech weeds. Now let's pull back out and connect all of this incredible engineering directly back to that price tag you see on the box. Why does this stuff make a motherboard so expensive? Let's start with a number, $4. This is roughly what a manufacturer pays when they're buying in huge quantities for just one of those high-quality integrated power stages we were talking about. $4. It doesn't really sound like a lot, does it? But here's the thing. To handle a beastly high-end CPU that's drawing a ton of power, the VRM can't just rely on one of these. It needs a whole team of them, all working together in parallel. So a top-tier motherboard like that MSI MEG X570S Ax Max from the list earlier, it doesn't use 4. It doesn't use 8. It uses 16 of them. And 16 times $4 is, well, $64. Yeah, just let that sink in for a second. the manufacturer's spending over $64 just on the power stages alone. That's before they've paid for the circuit board itself, the CPU socket, the capacitors, the heat sinks, or literally anything else. Suddenly, that huge price difference between the 19-euro board and the 450-euro board, it starts to make a whole lot more sense, doesn't it? And of course, that super robust VRM is the biggest reason for the price hike, but it's not the whole story. That extra cash also gets you a whole suite of other premium features. You get a thicker circuit board with more copper layers inside, which is crucial for stability and clean signals. You're also paying for faster networking, higher quality audio chips that actually sound better, more and faster USB ports, and even safety features like a dual BIOS in case something goes wrong. Every single one of these adds its own cost to the bottom line. So, at the end of the day, when you buy a premium motherboard, you're not just paying for a few extra ports or some flashy lights. You're paying for an investment in a superior electrical foundation for your very expensive processor. You're buying stability, you're buying efficiency, and you're buying the confidence that your hardware isn't going to be the thing that holds you back. And that really brings us to the final thought. The next time you're comparing two motherboards and one costs way more than the other, you'll know to look past the marketing hype. Because now you know that hidden under those big metal heat sinks is a complex, incredibly important power system, and its quality might just be the most important feature of all.